everyone. So this video is about the factories design patterns, which is talking about factory method, and abstract factory. And so these are three completely separate design patterns. And it's really important to distinguish between the three of them because they actually all they're used in different cases. They have different intentions. Okay, so depending on what you're trying to do, you might want to follow the factory pattern or the factory method pattern or the abstract factory pattern. So which one you use depends on what it is that you're trying to accomplish in your program and different use cases for each of these. Okay, so there's no like this is the best pattern ever and I will always use this pattern. That's not how programming works. Okay, so depending on the situation, you might want to use one of these three patterns. You might want to follow one of these three patterns. Okay, now as part of this, I'm also going to be doing an object-oriented programming review because I think that C++ was at least like 2 semesters ago, and at this point you might have forgotten a lot of it. So I'm going to also use this as a chance to sort of remind you about some of the things that you're supposed to remember from like BTP 300, okay, or possibly even stuff from BTP 200, okay. So let's get started. Now, out of these three patterns, factory method, and abstract factory, uh, only two of them are actually found in the Gang of Four textbook. So factory is actually not in the Gang of Four textbook. It's the one that is not actually in the text. Factory, however, is what you will find if you Google factory design pattern. So if you were super lazy about your Googling and you just say, I have the word factory design pattern, you Google for that, you're actually going to probably find the factory design pattern, which has nothing to do with factory method or abstract factory. So they do different things. So it's really important to understand what it is that they're trying to accomplish with each of the patterns. So let's start with So the three patterns are factory method, abstract factory. Factory pattern is supposed to be there to hide instantiation logic. So we'll talk about what that means in a bit. Factory method is to delay the decision of what it is to create to the subclasses, and also to provide a standard interface for the objects that you create. And I'll do an example where this will make more sense, okay? And finally, abstract factory is to ensure that objects that should be together get created together, okay? So we'll talk about what all of this means with an example, okay? So I'm going to start with a simple program. Let's imagine that this is my screen and I want to write a program where if I left click, I get a circle. If I right click, I get a rectangle. And if I middle mouse button click, I get a cube on the screen somewhere. Now, these objects, I want to be able to send them flying. So that means that the positions will change over time. So over every time, every 1/60th of a second, I will update each of these objects' position, and they will move around the screen based on that updated value. Okay, how I do that is irrelevant. Okay, but let's say that there's a way for me to change where this object is. I'll draw it in a new position 1/60th of a second later, and it'll look like it's moving around the screen. Okay. I could potentially, because I'm just creating objects as I mouse button click, I can potentially be adding circle objects, for example, like later on. So maybe if I left click a second time, I will end up with this object over here. Now, sometimes what that might mean is that as these objects are moving around, I might uh, cover one object with another. And we'll talk about all of this in a moment, okay? So let's start with this idea. How do I, first of all, create these objects? So what I would do is I would create separate classes. I have a circle class because a circle is not the same as a rectangle. To define a circle, you only need the radius, right? Like how wide it is, essentially. It's the same number no matter which direction you're measuring from. So we typically store the radius. We have the radius and the color of the circle. Then we have rectangle. Rectangle is length. We have to have a length and a width. And we also have a box, which is our 3D object, which has a length, width, and a height. So while I create it in different ways, what I want to do with all of them is I want to be able to update their position, and I want to draw it. Okay, so I have an update and draw function in each of them. And then what happens? Now, if I have these as three separate objects, then I can't put them into the same vector because you have to have the data type. So over here, circles get put into V1, squares get put into V2, and boxes get put into V3 because there's nothing in common with these. So I have to have separate vectors to keep these in, okay? Now, whenever I left click, I create a circle. Whenever I right click, I create a rectangle. And whenever I middle mouse button click, I create a box. And I put them into each of the three vectors respectively. Okay, so based on what I declare here, I put them in. And when I want to draw them, I have to draw each of these separately. So I'm going to draw all of the circles first, then all of the rectangles, then all of the boxes. Now, this is fine in some ways, but if you think about how we draw, typically what happens is if I draw a circle first and then a rectangle, then what happens is when I do this drawing, what will happen is I will put the circle over top, I will put it underneath the rectangle. So this rectangle, which I'm going to now color a different color, okay? Okay, this rectangle should cover, will this rectangle, if it's drawn second, will cover this circle, okay? However, the problem here is as follows. What I draw, if I want it to be based on when I added something, right? Like, so if I click circle and then rectangle, I want to draw the rectangle on top of the circle. But if I click rectangle, then circle, I want the circle on top. So depending on which one I click first, I want to draw it in a different order. Maybe that matters for some reason. I can't really do that with this code because this code says you draw all of the circles first, then you can draw all of the rectangles, then you can draw all of the boxes, right? This is what this says. So if I want to draw it based on simply how they were added relative to each other, I can't do that with this code. This is not actually possible because I would have to actually have some way of tracking which one was first, which one was second, which becomes pretty painful. So if I wanted to, if the draw order matters, the way that I have this will become really, really complicated, really, really fast. So I don't necessarily want to do that. Now, so what's the solution? The solution is we provide a common base class. So here, what I'm doing is I'm creating a base class called shape, and I derive circle, rectangle, and box from shape. So all circles are shapes. So this is that is a inheritance relationship. And a circle is a shape, a rectangle is a shape, and a box is a shape. Okay, the shape is the base, the circle, rectangles, and boxes are derived. Now, each of these, the shape class has two pure virtual functions. So making a function virtual, you just put the word virtual in. But to make it pure, you have to put equals 0. So what does this equals 0 mean? It means that the shape class does not implement update or draw. So there's no code for update or draw in here. And I don't just mean no code because I'm too lazy to fake code. I mean, the shape class will never actually have any code for this. It simply says that, hey, all update functions look like this. It's void return, no arguments. Same with draw, okay? So this is what we are providing with the shape. We're saying that this is the interface for these two functions. These two functions don't take any arguments, will not return anything. And when I write and because I have these two interfaces, it means that all of the classes that are derived have to say exactly what does update do. So will update change the position by going to the left or right? Or will it go up and down? Or will it go sideways? Whatever that update does is dependent on which class it's in. So circle updates a certain way, rectangles update a certain way, and they're drawn also differently. So update draw is dependent on the actual shape, but they all have the same interface. Now, what this means is that from the main's point of view, I don't really care which object this is because they all update and draw in exactly the same way. You call the update function, you call the draw function, and it will look at what the object is and then decide exactly how to implement, update, or draw. Over here, we are pushing circle, rectangle, and box into our vectors. So these are just creating the three objects and then putting it into the vector. Notice at this point, we only have one vector because we have a common name for all of these different shapes. They're all shapes. They're no longer a circle, box, or a rectangle. What gets created depends on which one I end up pushing in. Okay, now this still isn't design patterns. This is just review. Okay, now you've probably seen something very similar to this at some point in BTP 300 or 200. Okay, so this is just a review of those ideas. Okay, so make sure that you understand what an abstract base class is as well as what pure virtual functions are. Okay, an abstract base class is any base class that has one or more pure virtual functions. That's the definition. Um, and when it comes to some of the principles that we saw for Gang of Four, so if you don't know what I'm talking about, go back to the introduction video. Um, one of the principles is that we want to program to an interface, and we provide that interface by using abstract base classes. So it is better that our base class actually doesn't have any code in it. And you go, well, what if it's the same? What if I update the same way for every function? Wouldn't it be better to define it in the base? And the answer is no. It's actually not better to define it in the base because that means that now I've locked up how I want to do update for everything. And it has to, I have to take into account that all updates are this way in shape. But what if Circle wants to do something different? So I would still have to, I would then have to sort of implement it in different ways in different places. I would have to consider, and I would have to add that implementation to Circle. Or what is worse is what if I have to change the way shape works, and now suddenly it stops working for Circle or some other class that is derived from shape. So we actually want to keep our interfaces pure. We want to keep our abstract based classes without any implementation as much as possible. It's better that way. And instead of having to, instead of sort of like trying to save ourselves writing a function a second time, because that way, if I if I each of them have a function to do something, I can update it. I can update them separately. They're not all defined in one place. So this is we want to avoid white box reuse. We want to say, okay, all the code is, the way that I do the update is defined for Circle here. Okay, and either it's right here or it's wrong here, but it's here. Okay, so this is this provides us an interface. Now this is still not a design pattern. These are just ideas. Okay, now, the first pattern for design pattern has to do with this idea. So let's say that I wanted to make a small change to what I create. Instead of just randomly creating like circles and boxes and whatnot, I want to base how I create my box object based on what is currently on the screen. So if I have one circle, for example, I'll make this darker. If I have one circle, for example, um, every time I create my box, I want to make one of the sides equal to the number of circles I have plus one. The plus one is so that if I have no circles, I don't end up with something that's 0 dimensions on one side. So number of circles plus one. So if I have one circle, then one of the dimensions will have 2 units to it, okay? And I want to make the other one, okay, the one of the other sides, I want it to be equivalent to number of rectangles that I have, pardon me. Okay, so if I have two rectangles, then maybe this is like 3 units tall and so on. So the size of my box depends on what number of rectangles and circles and boxes that are currently on the screen. So what does that mean? Well, it means that I have to add what is called instantiation logic, right? So I can't just, sorry, if I go back to here, I would have to keep track of every time I do this, I would have to track how many circles I've created. And every time I do this, I have to track how many rectangles I create. And then I would have to change this to like not this. And also I have to track how many boxes I create. And then I would have to update these numbers, right? And you go, well, that doesn't sound that hard. I created a bunch of variables in main and I'm good, right? But what if you're not just creating objects in main? Like this is a really silly example. It's really simple. What if you have many, many source files and there might be different places where you actually have to create these objects? Then what happens? Pardon me. So if you have to actually create these objects in different files, you would have to repeat that logic everywhere. So everywhere you say new circle, you would have to say, oh, make sure you count the circle, which means that you have to have a variable that you can update everywhere. And that's not like that actually will either bloat your parameter list or you would have to have some sort of global variables. And remember, global variables are very bad. So we don't do global variables. So all of this means that this is probably not the greatest idea for us to actually have um, like a lot of like different instantiation logic. And what if this is so the idea for factory is we want to be able to hide all of these things that have to do with instantiation into something separate. We don't want people to be able to just like create these objects. We want them to when they create it a certain way, and they don't have to worry about like how many parameters there are or whether or not it's random or something else. So what we do is we create what is called a factory. So here I have a shape factory. And in my shape factory, I have three functions, one to create circles, one to create rectangles, and one to create boxes. Every time I create a circle, I count how many circles I've created. So I have some arguments for the factory that keeps track of these things. And whenever I create a box, I simply pass in the values for how many circles, how many rectangles, how many boxes, and it will automatically use those numbers to create my box object. Okay. And this is how the factory works. It hides instantiation logic. So from the user point of view, it's actually much simpler. I create one of these factories, and every time I want to create a circle, I just call make circle. Every time I want to create a rectangle, make rectangle. Every time I want to create a box, make box. I simply tell the factory what it is that I want to make. And if I need to do this in different functions, different objects, I just pass this factory around. Okay. And that will allow me to create these objects, these objects in various ways. Okay. So this just makes our code a little bit cleaner. And if I change my mind, I go, you know what? I don't want length. I don't want this to be circles to be length or rectangles. I want to switch these two arguments around. I only have to fix it in this one function, and automatically it's fixed everywhere I say make box. So this is the idea of factory. It hides the details of the instantiation from the client program. From the client's point of view, I'm making a box. You figure out how to make the box, okay? Factory, you know how to make the box, you make the box, and then I deal with it, okay? I deal with the box after that. So this is what factories do. They hide instantiation logic, okay? So the next pattern, so that one was not gang of four pattern. This one is called the factory method pattern. So I still have the same idea. I have the shape class, and that is an abstract based class. I still have circle, rectangle, and box that are created from this abstract based class. Still have update and draw. Now, the difference between factory and factory method is, first of all, their intentions are different. With a factory, with a factory, I have three functions for creating objects, but they all have different names. So the one for making a circle is called make circle. The one for making rectangles is called make rectangle, and the one for making box is called make box. However, for factory method, what I do is I have a shape factory, but instead of just having three functions in the shape factory, I actually create a separate class for each of the shapes. Now, this has a different use case. So let's pretend that I want to change what I want to do with my program. So let's say that I want to make a program, but this time, instead of having the three mouse buttons do something different, I actually want them to create the same object, but different numbers of them. So when I start my program, I'm going to decide whether this will be a program with circles, or a program with squares, or a program with boxes. And every single time I hit the left mouse button, I want one of those objects. So let's say I decided that it was circles. Left mouse button creates one object. Right mouse buttons creates two objects. And middle mouse button creates three of those objects. So this is what it's supposed to do. Okay, so left, right, middle, they just create different numbers of objects. And you can do variations on this, but let's say that this is what you want. Okay, so depending on which mouse button, different numbers get created, but they're all the same shape. Okay, all circles. So this is a different problem that we have now. It's not that I will get circle, rectangles, and boxes. I will only get one of the three. But depending on the situation, um, I will. I want to make sure that I don't do, I handle the code for handling left, right, and middle sort of the same way. So left means one of them, right means two of them, and middle means three of them. Okay, that's the difference. Okay, so how would I do this? Now, what you do in a virtual, sorry, in a in a factory method is you actually have two hierarchies. So what does this actually mean? It means that I have a set of products. So product is the shape. Shape, circle, box, and rectangle. These are the products of our that we're creating. So we're creating either circles, boxes, or shapes. And we have a parallel hierarchy. So so shape is the base, these three are the derived. We have a shape factory, which is the base of the factories, and circle, box, and rectangle factories are derived from the shape factory. So this is what we call a parallel hierarchy. There's two hierarchies, but they are they're basically the same. Okay, they have the same sort of shape to them. Okay, so shape has three derived, shape factory has three derived, and they are circle, box, and rectangle respectively. A circle factory only creates circles, a box factory only creates boxes, and a rectangle factory only creates rectangles. Now, the difference here is also, look at the function that is used to create this object. They're all called make shape. So in the factory version, they all have different names. So the one that makes circle is called make circle, make rectangle for the one that makes rectangles, and the one that makes boxes is make box. Whereas over here in the shape factory, they're actually all different. Sorry, they're all the same. They're not different function names. So the circle factory doesn't have a make circle, it has a make shape. Same with rectangle, same with box. So no matter what I create, the interface to create the object is make shape. It doesn't matter what object I'm creating, it's all make shape. So what happens here is that at runtime, I can decide from the user input or something like that, for example, what shape it is that I want to create. Okay, so I ask the user which shape, and they say whatever the shape is. And if it's circle, I'm going to use the circle. I'm going to create a circle factory. If it's rectangle, I create a rectangle factory. If it's a box, I create a box factory. And no matter what factory I create, doesn't matter which one I create, if I want to left mouse button click and make one left mouse button click, I simply make one of those shapes. And depending on which factory got created, that's the shape I'm making. So this is a different use case altogether. I'm creating the same interface for creating the concrete products, for creating circle, box, whatever, and it doesn't matter. Once I create the factory knows what it is supposed to create. I don't have to decide on that later on. So this is a really important idea. I'm actually separating, I'm deciding what I need, and then the factory will always pump out that thing that I need. Okay, so this is called a factory method. Okay, so sorry, so factory method creates the correct things based on the factory that gets instantiated. From the user point of view, I'm just making a shape. What shape? Well, which factory did you instantiate, right? So this is also a really important idea, the idea that we can actually create, um, like we don't actually, like we can actually decide at runtime what gets created. So this is why factory methods, it's also called virtual constructors. Now we all know we can't have virtual constructors. Constructors are concrete. However, using this pattern, we can basically mimic the idea that even object creation can be decided at runtime. Okay, so this is a very important idea here. Okay, that's factory method. Okay, now the last of the factory patterns is called abstract factory. And I'm going to imagine that we're going to make the game a little bit, we're going to make something a little bit different. So instead of just creating shapes that animate, I want to make a silly game. And I don't know what this game is, but for some reason, if we're going to call it the circle game, the rectangle game, or the box game. And the winning conditions are all different. So if you play the circle game, then the idea is that you have to make as big a circle as possible. That is the winning thing to do. Now, obviously, there's going to be some conditions and rules around this. We're not really making this game, so whatever those rules are, I don't really care. Okay, but uh, the idea is that the bigger the circle, the bigger the points or whatever it is. Okay, so that's for circle games. And there's also a rectangle game. And the rectangle, the farther to the right that you can put a rectangle, the more likely you win the game. And there's a box game as well. And for the box game, I can't remember what the logic was. For the box game, you want to make it as center as possible. Okay, so you want to put this as close to the middle of the screen as possible, then you will win the game. Okay, so it depends. Each of these has sort of like different winning conditions. Let's pretend that we somehow have some rules for this game that I will name after my shapes. So what does this mean? Okay, so let's say that I wanted to make this like this game where the user chooses what type of game to play, but then I would have to actually make the game, possibly with different UI, possibly with different things, right? So how would this work? Well, first of all, I still have the different types of shapes. So shape, circle, shape, rectangle, shape, box, whatever. Okay, I still have different type of shape. But I want to maybe make some AI bots that will play this game or animate it a certain way. So I want to create a player class. And what we do is we have a make move function. What does the make move function do? Well, depending on the game, it's going to, using the rules of the game, move a rectangle as far to the right as possible, make the size of the circle as big as possible, make the box be as centered as possible, whatever the code is to make a bot that will play this game correctly. But the function to do that movement is called make move for no matter what the bot is. Okay, so we have this idea of a player, and we have these bots that will play our game, and we write the code for how these bots will work here. Now we also have, so how would this game work? Well, we have to have a bunch of shapes that we're dealing with. So we have a vector of shapes. We also have a vector of players. And so we have the idea of shapes, we have the idea of players. Now, depending on the type of game it is, there's different number of starting players. So for example, the circle game, we might want to say, oh, it's only like 2 players, or the box game is always played with like a random number of players or whatever. You can make a decision as to exactly what the rules of these silly games are. Okay, but there's going to be a bunch of rules that dictate each of our games. Now, it would be, what we want to do is we want to make sure that if I wanted to play a game that involves boxes, I don't want to use the logic for moving those boxes based on the fact that this was the circle game, for example. So if this was a box game, I want to use logic that will try to move my pieces to the center. I don't want my box to grow as big as possible. I have different rules for these games, right? And so what this means is that we have a whole bunch of things that fit together, okay? And we don't want them to be created in separate ways. So if I'm making a box game, I want the shape of the things that I draw to be a box. I want the players to be a box bot, right? I want everything to be for it to be associated with the box game. So what I do is I actually create um, a, a factory that will create all of my objects that I need together. So we have a shape game factory, and we write a bunch of pure virtual functions that will define how each of the games work. Okay. And what we do is we basically say, oh, okay, so if it's a circle game, then my make shape will only ever make circles. My make bot will only ever make bots that have to do that know how to play the circle game. And how many players in a circle game? Well, it's 2 players. And how many shapes I start with? It's random. So these are the rules of the game, and I bake them into a single factory. That way, I'm not going to accidentally create the wrong bot because they are all together. So from the user point of view, when I write this logic, I ask them, well, what game are you trying to do? And depending on the type of game, I create the factory that is associated for that type of game. And all of the things that go together actually get created together. So the fact that I start with 4 players for the rectangle game, the fact that it starts with 4 shapes, okay, if those are the rules, I can bake those into this factory method, this abstract factory. And when I create my game, I simply have to say, oh, I need to create the right, I start with the right kind of factory, and automatically all of these things are going to be created correctly. Sorry, this should have said CF because it comes from the factory, right? So the abstract factory dictates exactly what these things are, and I simply make use of that when I write my game. So if I'm trying to make a move, I know that I use the correct set of bots to do it. If I'm trying to get the number of players, I have created even that within my abstract factory. So these are going to be correct for the game. They're being put together in one object. Okay. So that's the difference. Abstract Factory is also called a kit. That's its other name, kit. So if you think about a kit as like something that, like if you buy like a model ship building kit, for example, that model ship building kit is going to contain all the pieces that you need to build a model ship. Okay, you're not going to find an airplane wing on that ship model because unless it's I guess a flying ship, you're like it doesn't make sense together. Your model ship is your model ship, right? So you're going to get everything you need to build the thing that you need, nothing more, nothing less. And that's the idea for Abstract Factory. I'm going to get exactly what I need. I'm not going to accidentally create the wrong bot. I'm not going to accidentally create the wrong shape every time. I make a factory, and that factory knows what to do. Okay, so that's the idea for abstract factory. Okay. Okay. Anyhow, that's it for factories. Thank you all. Bye bye.